swimmable, breathable, and livable. That is our goal for the Minnesota River. Hi, my name is Tyler Schmitt, and today I'm going to talk about the drain tile filtration system that me and my friends created over this summer. First, we have to take a look and see how polluted the Minnesota River actually is. We can do this by using one or two of these resources that we found. The first resource is a statement made by the Minnesota Center for Environmental Advocacy, and they state the Minnesota River has suffered from severe pollution problems for years, mostly due to agricultural runoff and erosion. The second is a chart that was created by the Minnesota Pollution Control Agency that stated that 37% of all pollution in the river came from ag-related processes, and then that only 5% of all pollution is from urban areas. The two main pollutions that play a role in the Minnesota River are nitrogen and phosphorus. We created this filtration system to at least take out some of or all of these pollutions from the river. We can do this by using wood chips and iron-infused sand. The wood chips have bacteria in them that eat the nitrogen that is available in the water, while the iron-infused sand, when it comes in contact with phosphorus, it creates iron phosphate, which is a solid, and that can be removed from the water. Our samples, we took our sample as our control. We also took water from Tice Homestead, and we called that Tice 1. We also took water from Union Hill Field, we called Tice 2. So when we look at the results, we first see that the phosphorus levels aren't as high as the nitrogen levels. And that is because phosphorus is a compound that stays on the top of the soil, while nitrogen actually goes into the soil, and then that can be taken out at greater rates through drain tiles. When we look at the nitrogen though, we can realize that our filtration system is actually really effective. Because from Tice Field 1, we started off with 34.8 milligrams per liter and went to 0.13 milligrams per liter. And that Tice Field 2 went from 25.6 milligrams per liter all the way down to 8.97 milligrams per liter. Now both of these two are underneath the Minnesota Safe Drinking Water Standard, which is 10 milligrams per liter. Other components that play a role into river quality is buffer strips and chemical applications. Buffer strips is a piece of land that is between a crop field and any open water, whether it be a ditch, lake, stream, pond, or river. Chemical applications, if we can regulate and see how much applications of chemicals we have, we can help make the river better by using less. In conclusion, if we use those two processes, chemical applications and buffer strips, along with our filtration system, we can make the Minnesota River breathable, swimmable, and livable again. Thank you.